So in this first one, y equals the square root of x plus 6 plus 4, h is negative 6, which means it is shifted 6 units to the right. K is 4, which means it's shifted 4 units up. And A is 1, so it is not reflected at all. Okay, now let's come to this one over here. In this one, H is positive 4, so that means it's shifted to the right 4 units. K is negative 5, so that means it's shifted down 5 units. And A is negative 1/2, so it is reflected because A is negative. Okay, let's move to this one. H is positive 3, so that means it's shifted to the right 3 units. K is negative 1, so it's shifted down, and A is 1, so it's not reflected. Alright, in this example, H is 0 because there's nothing in that x squared. There's nothing with that x squared. This is the same thing as x minus 0 squared minus 3. So that means it's not shifted left to right at all. K is negative 3, so it's shifted down 3 units. And A is 1, so it's not reflected. Okay, in this example, H is positive 1, so it's shifted to the right. K is negative 5, so it's shifted down. And A is 1, so it's not reflected. In this example, H is 0 because this is the same thing as log of x minus 0 plus 3. So it's not shifted horizontally at all. K is 3, so it's shifted up 3. And A is 1, so it's not reflected. In this last example, H is positive 3, so it is shifted to the right 3 units. K is negative 1, so it's shifted down 1. And this is a circle, so it can't be reflected. Circle, circle. Alright, in this example, H is 0. It's the same thing as x minus 0 squared. K is positive 3, so that means it's shifted up 3 units. And that's a circle also. Now, in these examples, we're going to graph this function, and then we're going to tell everything about that function. Now, the parent function for number 1 is the square root of x. That's the stripped down function, the square root of x. It was shifted, remember, the horizontal shift is h. H is negative 1, so it's shifted to the left 1. K is your vertical shift. K is negative 2, so it's shifted down 2 units. A is not, A is positive, So there's no reflection. And so now you can use your calculator to graph this. In your calculator, you put y equals 2 times the square root of x plus 1. Get out from underneath the square root and do minus 2. Okay, and you'll see you can pick out some coordinates by looking at the table just to make sure you have it graphed correctly. -1, -2 is the coordinate. 0, 0 is the coordinate. And 3, 2 is a coordinate. This graph looks like this. And it makes sense because for the square root function, our starting point would normally be here. And if it shifted to the left one, then you'd come here, and down 2, you'd end up right here. Okay? And it still holds the same general shape. Now the domain, remember that's your x values. Your domain is x greater than -1. Your range is your y values. So your y values start at -2 and go up. So it's y greater than -2. And it actually equals -2. Because we know from this dot right here it equals -2. And it also equals -1. It's only the functions that have asymptotes that you don't want to put the equal sign for. Logs and exponents. Okay? Now, in behavior. So let's draw in our end behavior marks. In behavior, remember, is talking about your y values. Okay? In behavior is talking about your y values. So when I follow this, at the end, my y values continue to increase all the way to infinity. But if I'm coming down, my y values stop at -2. So f of x, as x approaches infinity, my y values also approach infinity. As x approaches -infinity, my y values approach -2. Increasing and decreasing, we're naming the intervals. The intervals of x. We're naming the x values where the function is increasing. So it's increasing from here all the way that way. So it starts at -1 and goes all the way to infinity. So it's increasing from -1 to positive infinity. And it's never decreasing. Look at our next function. The parent function. The stripped down function is the cube root of x. Okay. The horizontal shift, that's h. The vertical shift is k. Reflection. If a is negative, there's a reflection. So the horizontal shift, h equals +1. That means it's shifted to the right 1 unit. K is 4, so that means it's shifted up 4. And there is no reflection if a is positive. So you go and you graph it now. Okay, so if it were my parent function, my starting point would be right here. But my starting point's not there anymore. It goes to the right 1 and up 4. So to the right 1 and then up 4. 1, 2, 3, 4. So this is that starting point for my new function. And cube root looks like that. Alright? So now, domain and range. How far left and right is there? The domain is all real values, all real numbers. The range is how far high and low does it go? Again, all real values. Because although it goes to the left, it's still continuously going down to the left and up to the right. In behavior. in behavior. These y values are continuously increasing in this direction. And these y values are continuously decreasing in this direction. It will continue going forever up and forever down. And so as x gets larger, my y values also get larger. And as x gets smaller, my y values also get smaller. Increasing and decreasing. What intervals are x? What are the intervals of x where our function is decreasing and decreasing? Now remember, as you go from left to right. So as I'm going here, when I start here, these are getting larger and larger and larger and larger forever. So it's increasing from negative infinity to positive infinity, and it's never decreasing. All right, our parent function, square root of x. Okay? Horizontal shift, that's h. H equals 0, so there's no horizontal shift. Vertical shift, k equals 5, so that means it goes up 5. Reflection, a equals negative 1, so yes, it is reflected. Okay, now let's graph it. Negative square root of x, get out negative square root plus 5. Okay, so my original parent function, I'm going to draw the original and then the new. My original starts at 0, 0 and does this. Okay, but I have to take that and shift it. I don't shift it left or right at all, but I'll shift it up 5 units. So 1, 2, 3, 4. Okay, let me bring this down some. Let's do that again. So it started out here. We're going to go up 1, 2, 3, 4, 5. That's shifting it up 5 units. But now I need to reflect it, which means I have to flip it over. So this is what it looks like now. Okay, so that's my new graph. It's still at 1, 2, 3, 4, 5, and your calculator can graph this. But instead of going up like it normally would, it's reflected, so it goes down. Okay? And so domain and range. Domain is your x values. It starts at 0 and goes all the way to positive infinity. So that means x is greater than or equal to 0. Your range is your y values. Your y values start at 5 and everything's smaller than 5. So y less than or equal to 5. End behavior. At the ends, my y values they're decreasing, they're going down. So my y values go all the way to negative infinity. That's as x gets larger. As x gets smaller, my y values stop at 5. My y values stop at 5. So when x gets larger, y goes to negative infinity. As x gets smaller, it goes to 5. Increasing and decreasing, that's my x values. This function is never increasing. As I go from left to right, it starts here and continues to go down. So it's decreasing from 0 all the way to positive infinity. Okay, so I want you to try these and then check your answers. Okay, check your answers. So the parent function is x squared. It's shifted to the right 3 and up 4. It's not reflected. The domain is all real numbers. It's your x values, your range. Is everything y greater than or equal to 4? The end behavior is infinity at both ends. It's increasing from 3 to infinity here, and it's decreasing from negative infinity all the way to 3. Now you're talking about your x values here. This is where it's split. Okay? It's decreasing here and increasing here. Okay? For number 2, the parent function is absolute value of x. It's shifted left 1 and down 2. There is no reflection. The domain, it's all real numbers as you go from left to right. The range is y greater than or equal to negative 2. The end behavior is infinity on both ends. And when we're talking about our increasing and decreasing, it's decreasing up to negative 1, and it's increasing from negative 1 all the way to infinity. Okay, now I want you to try 3 and 4. Okay, you can check your answers. This square root was shifted 2 units to the right and 1 unit down. So what started out as here ended up here and went over 2 and down 1. The domain is all x's greater than or equal to 2. The range is all y's greater than or equal to negative 1. Function approaches infinity as x approaches infinity, and it approaches negative 1 as x approaches negative infinity. It's increasing from 2 to infinity. Remember, you're naming, when you're talking about increasing and decreasing, it's your intervals of x. Number 4, parent function is the cube root of x. It's not shifted horizontally at all, it's just shifted up 2, and there's no reflection. For cube root, the domain and range is both all reals. As x gets larger, the function approaches positive infinity. As x gets smaller, the function approaches negative infinity. And it's increasing the entire way. As you go from left to right, it continuously goes up. Now, remember, the base doesn't change for exponentials and logs, they're parent functions. So I'm listing the parent function for number 5 is, the base is 1/2, so that it's just 1/2 to the x power. That is my parent function. Okay? Now, what's happening up here, that's your h. So it's shifted 3 units to the right. Because h is 3. K is 4. So it's up 4. It is not reflected at all. And so now we'll graph it. Okay, exponentials have a horizontal asymptote. Instead of being at 0, it's going to be at 4. So my graph now looks like that. Okay, somewhat like that. My domain is all reals. My range is y greater than, can't equal it, greater than 4. This is 4. So y greater than 4. As I go to the left, this approaches positive infinity. As I go to the right, it approaches 4. It never goes past 4. We can't say negative infinity because it never goes past 4. So, as x gets larger, my function approaches 4. As x gets smaller, my function approaches infinity. As I go from left to right, it is continuously decreasing. So the intervals for which x is decreasing is from negative infinity to positive. And it's never increasing. For number 6, my parent function is 2 to the x. The horizontal shift is to the right 2. My vertical shift is up 2. Is it reflected? Yes. So now we'll graph it. Okay. I have a horizontal asymptote at 2. Then my function looks something like this. So as I move to the left, the end behavior, as I move to the left, it's going to approach 2. And as I move to the right, it's going to approach negative infinity. My domain is all reals. My range is all y's less than 2, not equal to 2 because it's an asymptote. As x gets larger, my function goes to negative infinity. As x gets smaller, my function approaches 2. It's never increasing because as I go from left to right, it is continuously decreasing from negative infinity to positive infinity. Lastly, we have some examples of logs. So my parent function, remember the base stays the same. Log base 5 of x. This is h, so it shifted left 4. I don't have anything for k, so there's no vertical shift. A is positive, so there's no reflection. So now let's graph it. With logs, you have a vertical asymptote. My vertical asymptote is at negative 4 because it started out being at 0 and it shifted to the left 4. So 1, 2, 3, 4. So there's my vertical asymptote, and it looks like this. Something like that. Okay, so my end behavior, as x goes to the right, my y values continually increase, and as x goes to the left, my y values continually decrease. The domain, that's my x values. This is negative 4. So it's x greater than negative 4. My range, all reals. As x gets larger, my y values also get larger. As x gets smaller, my y values also get smaller. It's increasing. Starting at negative 4, all the way to infinity. And it's never decreasing. Increasing the entire way. And lastly, number 2. My parent function is ln of x. Horizontal shift is 0 because this is the same thing as ln of x minus 0 minus 1. So h is 0, k is negative 1. So it shifted down 1. There is no reflection because a is positive. So now let's graph it. You need to make sure that when you put it in your calculator, you close your parentheses around x. Okay, it wasn't shifted horizontally at all. So my vertical asymptote is still at 0. However, it was just shifted down 1. So it just looks something like this. This approaches positive infinity as it gets larger, and negative infinity as it gets smaller. The domain is all x's greater than 0. The range is all y's. As x gets larger, so does y. And as x gets smaller, again, so does y. It's increasing the entire way. So it's increasing from, remember, it's your intervals of x, 0 to positive infinity. And it's never decreasing.